Hello, everyone. You are welcome again. I thought I started recording the other time, but now I have to just go through the introduction. So this is our first post boot camp class together. As part of the deliverables is that at least once a month we're going to be meeting to run projects together. Uh, the list is once a month. It might end up that we'll be having projects once every week, okay? Or we might be having twice a month, okay? But you can be assured that we will not allow you sleep on the skills that you have acquired during the boot camp, okay? So what we're going to be looking at today is just a simple interview assessment that was given to one of our past trainees, and he was asked to complete it within a short duration, I think about 48 hours. And the organization sent him a login access to their external portal for him to upload his response, and then they can thereafter take it up from there. Okay. And he completed it, and graciously he got the job, and he has been working for some years now. So it's important that we look at projects that can be quoted on your LinkedIn or GitHub, or that you can uh, tell prospective employers that this is what you have been laying your hands on. Okay, so the interview says create a deployment of an EC2 instance using Terraform with specific parameters. The parameters are T2 micro, talk about the instance type. Okay, we know T2 micro uses elastic elastic what's it called now, EBS, elastic block storage. So it's going to be 12 gig. The instance will be in the London region. It also says access to SSH and RDP from a single IP address, and access to HTTPS from anywhere. Okay, so we'll be looking at this together. Before I continue, can everybody hear me loud and clear? How is my audio? Is it clear enough?
Yes.
Yes.
All right, thank you. So this project is silent on many things. Okay. Uh, this assessment rather is silent on many things, and chief of what it's silent on is VPC. The assessment does not specify if we should create a VPC or not. But from experience, I've always known that in production, ensure that you encapsulate all your infrastructures or your resources within your own custom VPC. Okay? Ensure you keep them within your own custom VPC. And it is on that note that we are going to be looking at these stepwise solutions. Okay? I have repeated the question here. Can you all see my notepad, please? The title says Post Boot Camp. Can every one of us see it?
Yes, we can.
All right, so please, I will encourage you to give me early responses so that we can move as fast as possible. So, about 9 steps, which we will first answer the assessment. Then we will now expand these steps for further learning. Okay, it should not take us more than 1 hour to complete this. It is assumed, not assumed, it is believed that everyone here has passed through our boot camp. So there are so many things I will just glide over. I will not be doing how to, We'll just be picking our tools and then we'll be using them. The first step here says we have to create a VPC. After we create VPC, we're going to create Internet Gateway IGW. Okay. Since we have seen that the security group or the firewall around the instance can address to HTTPS from anywhere. Anywhere means internet. So that means the VPC must be publicly accessible. And for that to happen, you must have an internet gateway. Next, we're going to create a custom route table, which is actually going to be a public route table. All right. And we know what a public route table means. It means that it has an additional route which routes to the internet gateway. Then since we have a public route table, we're also going to have a public subnet. A public subnet is that subnet that is associated to a public route table. I hope we all still remember this. Next, we're going to associate the subnet with the route table so that the subnet can become public subnet indeed. The next, we're going to create security group. On AWS, security group is what we generally refer to as firewall in the IT parlance. All right. Next, we're going to create a network interface with an IP address in the subnet that was created in step number 4. Okay. So a network interface will always have 2 IP addresses. The local IP address if it were to be on-premise, and then the public or the static IP address if it were to be on the internet. In AWS, the local IP address is also called the private IP address. So within the decider that we will give to the subnet in number 4, we will pick an IP address for that network interface. Why do we need the network interface? It is because of number 8. We'll be assigning an elastic IP address. So you will see that this assessment is silence on many things, okay? It is expected for us to know that if this EC2 instance is going to be playing on the internet, then it is going to need a static IP address, all right? And AWS best practice is that you do not put IP address on the instance directly. Where do you put it? On the network interface. That's why we are creating number 7 and number 8. And at number 9, we're going to launch the EC2 instance. And we are also going to give it 12 gig storage as against the default 8 gig that T2 Micro normally have. Okay, so this is what we're going to be doing. Do you have any questions before we move on? All right, so if there are no questions, let us start. The first thing we're going to do is to go and create the folder for this assessment on our VS Code. Okay, so this is my VS Code. Can everyone see my VS Code, please?
Yes, you can see it.
All right, so let's go create a folder. So I'm going to be creating a folder outside of the VS Code and then, or let me just create directly from the VS Code here. Let nothing be hidden. Okay, so I always save anything that has to do with projects, either demo or live projects on Drive C, because I know that within my drive C, things are safe. I don't put them on, desktop. So let's have a new folder here and let's call it mobile post bootcamp. Okay. And then within that, let's have session 1, if that's a good name to call it. So we select the folder and then it comes to our VS Code to set it up. I should tell us 1 or 2 things. Okay, I think I've told us, but let me just reiterate. For our infrastructure or the provider, we're going to be using a cloud platform, which is AWS, Amazon Web Services. The environment is going to be Terraform, and the language is HCL, HashiCorp configuration language, and our integrated development environment IDE is VS Code. Okay, so here our session 1 has started. Don't forget, when you download and install and commission VS Code on your PC, either of the operating system your PC is running on, say it is Windows or it is uh, Mac OS or Linux, ensure that you bring in the necessary extensions for you to be able to work with Terraform on your VS Code. Okay, extensions like HashiCorp configuration language for AWS, Azure Terraform, and all of that. Okay, like I said, this is supposed to be a post uh bootcamp session. It is expected that we know some of these things, right? So the first file we're going to have here is our provider.tf. Okay. If I succeeded, I thought I've done that. So I actually thought I've disabled Copilot. We will not be using it. I'm not saying it's not bad, but for a reason, I wouldn't want us to use it so that uh, we don't build too much dependency on Copilot. Of course, these things are here to make life easy, but it's important to also understand these things as well so that you can guide these generative AIs when they are going overboard. All right. So the first thing you do when you want to start a Terraform project, after you have installed and commissioned Terraform and you have brought in the necessary extensions, is to declare your provider. Provider on Terraform refers to the platform where you want Terraform to go and automate provisioning of infrastructures for you. Okay. And Terraform is such an easy to use tool such that all the necessary documentations are available on their platform. So let's go and bring in our provider. From your browser, just search for Terraform, AWS, or Terraform, followed by provider, followed by AWS. Okay. And then be sure of the link you click on. The link that says terraform.io takes you to the real Terraform platform. All right, so here we are, AWS provider on Terraform website. Okay, so this is an example of how to create your provider. And all you need to do is to copy. However, we will not be copying the VPC script with it. We're just going to copy from here to this point. Okay. And then we'll paste here. So let us say if we were to work with other providers within this project, all we need to do is to come here, you tab down and declare for other providers. Say you want to bring in Azure. At line 7, you put in Azure, the source and the version, which you can also see on the documentation for Azure on Terraform. But since we're not doing that, there will not be need for us to have idle lines so that we can have a clean code. Okay. So it says configure the AWS provider region US East 1. But then we know that the assessment we are working on is to be carried out where? London region. So what do? We change this region here to London region. If you go to AWS platform, the region on AWS platform that talks about London region is EU West 2. Okay. Come in, give me a moment. Let me quickly get on so I can connect from there. All right, so while we are waiting for that, let's change this to EU West 2, shall we? EU West 2. That is the code for London region. All right. So I think we should have a readme.markdown file here so that we can have the steps to our solution all in one place. What do I do? Let's create a new session and let's call it readme.md. Okay, and what are we going to do with that? I'm just going to copy all of this and then I'll put it here so it is easier for us to have all this in one place. Okay, so now that we've brought in our, now that we have declared our provider, the next thing important for us to do is to give Terraform the necessary login details so that when it gets to AWS and it is being asked to for authorization, it will have the necessary login details. So what do? We'll come here, still on our registry, look at this provider AWS region, US West 2, access key, secret access key. So what we need here is the programmatic access. Okay, instead of copying all of that, I'm just gonna paste it in this place. However, because this is a public domain, all right? Not only because it is a public domain, it is not advisable that you had code your CLI credentials, okay? Especially if at the end of the day, you're going to be pushing this configuration script to a particular repository, either on GitHub or wherever the assessor has asked you to push it to. It is not appropriate that you had to code your credentials. If you get into the wrong hand, they can also pick it up, signing into your AWS account behind you and do many unwanted things. So we're not going to be hard coding this. I'm just showing you in case you are working solo, you will not be sharing your code with anyone. You can add code your details, okay? But if for any reason you know that other eyes are going to be seeing these configuration files, then do not hard code your login credentials. Okay, so what we're going to do is just going to comment out this part. How then are we going to log in? We'll sign in directly into AWS from the CLI terminal. Okay. Remember, when you download the AWS CLI, the CLI is integrated with your PC's local command line interface. Either it is PowerShell that you are using, or it is CMD on Windows, or it is Terminal on your Mac OS, or it is shell prompt on your Linux. Okay, so this is what I have here. I obviously have installed AWS CLI on my PC's terminal. Okay, so instead of coding the details here, I'm just going to sign in this place. And how do we do that? We run AWS configure. Okay, and then those details you want to put in this place, you put them here instead. Okay, so I'm just going to let's just wait for AWS configure to be out. Okay, look at that. So this is it's asking for AWS access key ID. So what you put here is your AWS access key ID. Now, please do not forget that it is inappropriate to generate programmatic access as a root user on your AWS account. You are most powerful and also most vulnerable. What do you do? Create an IAM user and give such user administrative access, full admin access, and then create command line credentials, programmatic credentials for such IAM user. All right. So what I'm going to be putting here now is the uh, command programmatic access for the IAM user that was created for me as a consultant on the mobile AWS platform. So shortly, I'm going to unshare this screen so that I protect my privacy. So please bear with me. I'm just going to remove that from what I'm sharing at the moment. So what I'm doing is I want to enter the access key ID. Okay, I've done that. I'm still going to show us after I've inputted them so that you can see what I've done. EU West 2 JSON. Okay, so let me clear screen. Let me confirm I'm signed in. Okay, so I'm just going to share the screen now and show you what has happened. All right, so let me run the command again, AWS configure, and then it's going to ask for my AWS access key ID. Because what is in this bracket is what I want to enter, I would not need to enter it again. I'll just tap enter on my keyboard. But if it is your first time of ever signing in into your AWS, know that you will find none inside this angular bracket. Okay, so I've inputted that and I tap enter. Also the secret access key, tap enter again. I'm working from EU West 2, which is the London region. And then the output format is JSON. This is the appropriate way to write JSON. Okay, and then I can clear. For me to be sure that I've truly signed into my AWS account, I can decide to use any of the AWS command, which is AWS S3 ls. This command says list all the S3 buckets that I have on my AWS platform for me. If I'm able to list that, then I can categorically say I've truly signed in. So it says I have mobile rent zone web files and I have that elastic stock. So I know I'm inside the AWS account. Now let us move on. So we have declared the provider to be AWS. And then what we need to do is to save. 2 here shows that you have 2 files unsaved. And on each of the file tabs, you see a white dot. It means you have not saved this particular file. So starting with provider.tf, if I run Control S, you see that the dot has disappeared and the 2 here has also reduced to 1. If I'm going to save this markdown file as well, Control S, save, right? So we have saved. What do we do next? We initiate Terraform. So we run Terraform init. So what will Terraform init do for us? It's going to read all the files that we have thus far, and then it will bring in the necessary things it's supposed to bring in. Things like the plugins for AWS. All your providers is going to read them and bring in the necessary plugins for those providers. In our provider.tf file, we only have one provider declared, so we expect it's going to bring in the plugin for AWS. Now, if you pay attention to the files we have here, it's just 2. After successful initialization, these files here will increase, okay? So while we are waiting for initialization, do you have any questions to ask? Let me know if you have any questions to ask, please. Hello, are we together?
Yeah, we're together, sir.
All right. Okay, so I'm in my London region here, and then this is the code for London region. Look at it, EU West 2. All right. Okay, it is still initializing. Look at it. The first file .terraform has arrived. The dot here, what does it mean for this file? Anybody knows? You have a dot before a name. What did we say that means in Linux?
In that directory.
No, sir.
Hidden. It's a hidden file.
Thank you. It is a hidden file. Thank you, sir.
Yeah.
All right. So while we are waiting for initialization, can we create a new file? Oh, okay. So successful. Terraform has been successfully initialized. You may now begin working with Terraform. Try running Terraform plan to see any changes that are required for your infrastructure. All Terraform commands should now work. Okay. So we've initialized Terraform successfully. Let us move on. See, we now have double files, .terraform and then .terraform lock HashiCorp configuration language. I'm sure these files were explained to you during the bootcamp. Let's create VPC. So we're going to have another file. We call it vpc.tf. Please, mind you, I can have all my configuration files in one single file, but it's just going to be too clumsy. All right, so that's why it's advisable that you modularize your configuration files whenever you're running a Terraform project. So what's the first thing we want to do? We want to create VPC, isn't it? So let us create VPC. And then how do we create VPC? We come to the documentation as usual on Terraform registry, Terraform provider AWS. Please confirm you can see my browser, everyone.
Yes.
All right. That sounds like Mr. Chidozie. Is that you?
No, it's Sam.
Oh, Mr. Sam. Welcome. So this is Terraform registry, and we are under AWS documentation. So if you filter here, you can filter for VPC. It's going to show you all of VPC results. And then if I scroll down, look at VPC here, Virtual Private Cloud. It is expanded already. Trying to collapse it and see if I can. Okay, so it has already been expanded. And what we want to do is to create VPC. It is a resource, not data. So we'll look under resources and we are looking for AWS VPC. Look at it here. So you click on this AWS VPC, and this is it here. Okay. So this is resource AWS VPC main CIDR block, the tenancy, and then tag. We're also going to be adding some things with it. Okay, so what do we do? Let's copy all of this. We come and we paste in this place. All right. So this is a resource module. This is a resource block rather. Okay. What follows after the resource keyword is the resource type. And what follows thereafter is the reference name for that resource type. I'm sure you must have been told during bootcamp that this reference name is only useful within this configuration file. It is not useful outside of here. And what is it useful for? It is used to refer to this particular resource type. So anywhere within this our configuration files, we want to refer to this VPC. This is the keyword we're going to be using. However, it is a custom word. You can change it to suit your own. Okay. So who was the first person to join the class today? I think it was Mr. Sam, yeah?
Yeah.
It was you. So we are tagging you for today's class. So this is going to be Sam VPC. Okay. I like to give my reference and tags the same name. Okay. So let's call this VPC. I might also want to add to the tag. Let me put an environment. Okay. Let me call it DevOps environment. Okay. So what CIDR block do we want to use? Mr. Sam, give us a CIDR block to use. We don't want to use the default 10. Just give us any number.
I say 25.
25.0.0.0 CIDR 16. Okay. All right. So for those who are fast, how many IP addresses do we expect to have on this block within this range, CIDR 16? How many IP addresses? Anybody remember? Who wants to do a quick calculation? Say that again, sir. You're asking us to go and calculate. I'm asking for the IP addresses. You say 2 raised to power what? So what's 2 raised to power 16? Or you also train it back to us. Is that what you're doing, sir? Is anybody punching calculator? Anyway, while we are doing that, let's move on. All right, so remember, when you create a VPC, you always enable DNS host name. Is that correct? Okay. So why don't we enable DNS host name here? And why do we enable DNS host name? The response is true. Anybody knows why we enable DNS host name? So that any resource that requires DNS host name, it can be given to it. All right. So you now be wondering, oh, you're picking this from your head. It's in the documentation. Within the documentation, any other thing you might want to add to the particular block is always available in this place. Look at it. Enable DNS support. It is optional. A boolean flag to enable or disable DNS support in the VPC. The default is true. Default is true means that if we had not declared it, what we're going to find there is what? True. But look at host name. The default is what? False. So if we had not declared it, it will automatically be what? Disabled. That's why we now have to what? Declare it. Now, how do I now remember, or do I know that I'm supposed to include these two or other ones when I am using Terraform? That depends solely on your knowledge of the provider platform. Okay. Terraform is not a tool you just jump into and begin to learn. You first must have mastered a particular provider platform. So it is only those that knows this from learning VPC on AWS that we know that, okay, even though the initial configuration file did not specify in this place to enable DNS support and DNS host name, But because I've known this while I'm working with AWS, VPC on AWS, I have to enable it. Okay. So moving on from there, we have simply created a VPC. Okay. The next thing we want to do, let's look at our steps, is to create internet gateway. So let's go and create internet gateway. We come to our documentation, still within VPC, we come and create internet gateway. Look at internet gateway here, AWS internet gateway. So what do? It's as simple as this. We copy this and then we return and we say create internet gateway. I forgot, let me copy the step and also repeat it here. As usual, another resource block. The resource type this time is what? AWS Internet Gateway. And the reference name that comes with it is what? GW. But then we're going to call it SAM IGW. Okay. I'm going to just repeat these two tags here. All right. SAM IGW. The environment remains DevOps. Okay. Now, this internet gateway needs to be tied to a specific VPC, and it is requesting for the VPC ID in this place. But you know that the VPC we want to tie this internet gateway to is the one we created at number 1 here, and it does not have an ID yet. Assuming the VPC have an ID, it's just to go and copy it from the GUI, or we come to the command line here and run a command like AWS EC2 describe VPCs. Okay. If we say AWS VP2 describe VPCs, it's going to load all the VPCs we have in that region we are signed into for us. Okay, so I'll just enter that. I know I'm only going to see the default VPC in the London region, except if the other consultant has created another VPC within that region. Okay, but let's not be distracted. Focus on what we are doing here. Anyway, let's finish up. It has loaded some VPCs for us. Where it has says more, can you see that? And that's all. The only VPC we have here is the default VPC. Okay. And this is the VPC ID. But that's not the VPC we are tying our internet gateway to. The VPC we want to tie our internet gateway to is the one we have here. It does not have an ID yet. So how then do we specify the ID? Look at the format HashiCorp provided for us here. That if you want to refer to an ID of a resource that has not been created, this is how to do it. The name of the resource type followed by the reference name of that resource type followed by ID. The name of the resource type dot the reference name dot ID. Okay, so if we want to specify the ID of this AWS VPC here using this format, what's going to change in this place? Work with me. What's going to change? Beautiful. All right, so this main change to what? SAM VPC. This reference in this place. So remember, I told us that this reference name is only useful within this configuration file. Outside of this place, it's no longer useful. Okay. And do not make mistake of taking this reference name for the tag. No. All right. So as simple as that, we have declared that this internet gateway should be tied to this VPC that we have in this place. What's the next thing that we want to do? We want to create a custom route table. Why are we calling it custom? Why don't we say create a public route table? Okay, so what do? Again, we come to the documentation. Still under VPC, we look out for route table. Look at it here. So we copied, we click on this. And look at it. Resource, AWS route table, the reference name example, the VPC ID, additional route, okay, for IP version 4, for IP version 6, and then the tag. So let's copy all of this, and then we return to our IDE and paste. We begin to amend accordingly. This reference name is going to be SAM public route table. Okay, and before we forget, let us also put it as our tag, SAM public route table, and let's give it another environment DevOps. So let's begin to edit the rest accordingly. Our VPC ID is going to carry what? This example will change to what? SAM VPC. Okay, let's save. Before we move too far, is there anyone in this class that doesn't understand what we are doing in this particular VPC ID, especially at line 16 and also at line 26? Is there anyone who doesn't understand? I want to be sure I'm carrying everybody along. So you all understood what I did at VPC ID. Are we together?
Yeah.
All right. The next thing is this route. Since it is going to be a public route table, the additional route here goes to where? Internet gateway. What will be the CIDR block for internet gateway class? What's going to be the CIDR block for internet gateway?
Cider block of the VPC.
Of the VPC. 25.0.0.6/16.
Oh, Lord have mercy. That's not correct.
Oh,
Internet
public.
gateway, IGW. CIDR
that's the
block for
private.
internet gateway.
I think it's pointing out to the internet. So 0.0.0.
Beautiful. 0.0.0.0. CIDR what? 0. Internet gateway is it's going to the internet. Internet means where? Anywhere, isn't it?
Anywhere.
Ah,
Anywhere. Mhm.
so this is the CIDR, the route for what? Internet gateway. Okay. Do you think we're going to change anything here? Look at this. Are we changing anything? The ID of the gateway ID.
We're changing the reference name.
Oh, beautiful. So what are we changing in particular?
Example, that example tab.
Thank you.
Example.id.
Thank you. Thank you. All right. I'm enjoying the contribution. Beautiful. So we change it to what? SAM IGW. Okay. Because we do not have the ID of the internet gateway already, but we have declared it here. Then we use the what? The resource type dot the reference name dot ID. Okay. A very quick check. Look at the variable here. What kind of variable is this? For those of you, oh, we didn't do Python in that bootcamp. Okay, so I'm gonna bookmark
Boolean.
that.
Boolean.
Yeah, Boolean. Okay, a Boolean variable is that I have just two outcome, true or what? Or false. This particular one, what will you call it? What variable type is this? String.
A string.
This is string. Okay, you see it here already. See, when I put my mouse on true, it says short word for Boolean. Okay, we also have other ones like integers, like float, all of that. But we'll be learning all of those together. We're not using we won't be using IP version 6. What do? We comment it out. But if you don't want to comment it out, if you want to leave it, this is also anywhere. Okay, all you need to do is just to change the reference name here to your own. Okay, but already commented it out, we're not using it. So now we have a public route table. Let's move on. It says we should create a subnet. Okay, so we come here, look at AWS subnet. And this is it. Resource, subnet, all of that. Then we'll say copy. And let's paste. Again, let's call it create a public subnet in what? Which of the availability zone? In EU West 2A. Okay. So first we change this to SAM public SN. All right. This VPC, this guy will change to SAM what? VPC .id. The CIDR block. This CIDR block here must be a sub within our VPC CIDR. Don't forget that. So let's use CIDR 24. So we're going to say 25. Dot 0. Let's not leave any block at 24. Okay. We need to give it a subnet. No, we're not giving it subnet. What are we giving it? Availability zone, isn't it? Availability zone should be in EU West 2A. So we know that this public subnet is being created inside EU West 2A. And then look at our public subnet 2A. I think it's sensible that way. It is a custom name, don't forget. So you can change it to what you and your team agrees to. We've done number 4. Then let's move on. What's the next thing? it says we should associate our subnet with the route table. Okay, so we come here as well. We search for what addresses what we want to do. Look at it. AWS route table association. AWS route table association. Okay. This one is associating subnet ID with route table ID. This one is associating gateway ID with route table ID. Which of these two suits our purpose? Are we together?
I
Hello,
think the
can you
second
hear me?
one, the second one, the second one.
Gateway versus route table. Is that what every other person says? Okay, it is the first one. What we have here is what? Subnet and what? Route table. Isn't it? We also have internet gateway, but we have already associated this public route table with the what? Internet gateway, haven't we? Look at the additional routes we create here. All route tables by default are what? Do you all remember? But when you create a route table by
All route
default,
table by default is private.
beautiful. All route table by default, they are all private. So this additional route we added here, we say it should route to where? Internet gateway. So we know that this public route table already carries a gateway. So what are we associating? We are associating this subnet with the route table so that this subnet can truly become a public what? Subnet. So if you look at it critically, this is the one that suits us. Subnet ID and what? Route table ID. So let us copy this and then paste. Okay. Let's change this to SAM A. And then we know the subnet ID here is going to be what? The reference name of our public subnet, SAM public subnet 2A. And the route table here is going to be what? SAM public route table. And as simple as that, you have associated the subnet to the public route table. And then you can now truly say this subnet is now a public subnet. Okay. What's the next thing? Gradually, we're moving on. We have to create a security group. Okay. So let's go look at security group here. Scroll down. Look at this. Security. This is for ingress rule. This is the one specifically for security group. Okay. Security group, they have egress. What we need is for ingress. So we're going to combine this guy and this guy together. But what do we need here? We only need the what? This block. Okay. So we copy all of this. I'm not bothering to explain this because I expected that we have learned this during the bootcamp. The security group. And then we paste here. What do we call it? Let's call it SAM. It's gonna be a public SG, SAM public security group. Allow TLS description, allow TLS inbound and outbound traffic here. Which VPC are we you can change all of these, please. Don't think it is strict though. It is custom. Okay. I can call the name of a public security group the same thing I called the reference name, SAM public security group, SG. Okay. Description, I can add the description of the task here, which is allow SSH. I can say access to SSH from anywhere, and okay, HTTPS from anywhere. Simple as that. We need to tie it to our VPC ID. So what's going to be here? SAM VPC. Okay. So what do we do next? We need to begin to bring in the rules. Are we together, everyone?
Yeah, but we have to target.
Say that again.
No, I'm just asking if you're going to target. Give it
Oh,
a name.
yes, we're going to target. We're going to target, but we need to bring in the rules, don't we?
Yes, sir.
Okay.
The other rules.
All right. So
Yes, we do.
say that again.
I said yes, we do. We have to bring in the rules.
Yes, we need to bring in the rules. Okay. And then the first rule is what?
SSH, that is allow
Okay, so
SSH protocols for 22.
look at this. Let's first bring in this. But instead of it being an ingress, what is it going to be? Egress. What's it going to be?
Ingress.
Ingress.
Beautiful. Ingress.
Ingress.
Ingress. Okay.
Incoming traffic.
It says SSH first. So what's the port for SSH?
22.
To where? 22. What's the protocol? TCP, right?
Yes.
Okay. The CIDR block. Are we using CIDR 16? No, so comment it out. The CIDR block, it says from a single IP address. From a single IP address. So, and they did not specify for us that IP address since it's an assessment. So let's just take an arbitrary IP address here, 197.167.100.20. CIDR what will be here?
32.
I didn't want you to see that. So why is this at 32, by the way? Explain.
Because it's a single IP address.
How do you know it's single IP address?
So the 32, that's just what I mean.
No. I mean, that's not substantial or substantiative. Back up your claim. How is 32 a single IP address? I could have said 30, and I say it because it is single IP address. Back it up. Back it up. It's 32, yes, but back it up. Anybody wants to back that up? I'm looking for my whiteboard. Anybody wants to back 32 up? Okay, let's go to the board and do some explanation.
2 to
Are we
the
still
power of
together? 2 to the power of what?
2 to the power of 0.
Excellent. How did you get 0, sir? How did you get 0?
Because that is the last bit.
Okay. Did anybody get that? Okay, work with me now. 25.0.0, whoever that person is, your network is needs support. Look at this, CIDR 16. Now, in the rule of CIDR, classless inter-domain routing, whatever number you see here, what it means is within this IP version 4, out of the possible 32 bits that a typical IP version 4 can have, this value here, 16, has been used. How do I know that there are 32 bits in IP version 4? In a typical IP address, there are many octets. How many octets do you have in IP version 4?
8.
No, 4 octets.
Okay.
Okay. If I write 168.192.130.25, this is octet, the first octet, the second octet, the third octet, the fourth octet. What you have within, I can see mouses moving around. Please let everybody be still this period. Okay, remove your hand from your mouse and be still. Okay. These are 4 octets here. 1, 2, 3, 4. For a typical IP version 4. Okay. Within an octet, you have 1 byte. Okay. So if 1 octet is 1 byte, how many bytes do you have in 4 octets? 4 bytes, isn't it? Please participate, class. I want to be sure we are moving together. Participate. Okay. 4
Yes, sir,
bytes,
according
isn't
to,
it?
to
I don't
4
want
bytes.
mouses to be moving around. Stanley or Baize, I can see your mouse hovering on my whiteboard. Okay, let everybody be still this period. Okay, just look at this. All right, so a typical IP version 4 has 4 bytes. All right, now 1 byte is equals to 8 bits. If 1 byte is equals to 8 bits, then 4 bytes will be how many bits?
32.
4 bytes will be 32 bits. All right. So in this IP version 4, in any IP version 4, you have a possibility of how many bits? 32 bits. That's why I got this 32 here. So when you see a CIDR like this, CIDR 16, CIDR 28, a CIDR can take place from CIDR 0 to CIDR 32. But on the AWS platform, for your CIDR on AWS platform, it can only be from CIDR 16 to what? CIDR 28. No virtual network on the AWS platform can be bigger than CIDR 16, and no one can be smaller than what? CIDR 28. That's why most times when you are creating your own VPC, you're either using CIDR 16 or CIDR 17 or CIDR 18 or CIDR 19 all the way to CIDR 28. You can't use CIDR 15 upward, neither can you use CIDR 29 to 32. No, it must be within CIDR 16 to CIDR 28. Okay, so we are now saying in this possible CIDR here, out of 32 bits that the IP version 4 can have, this value you see here, whatever it is, has been used. So it's going to be 32 minus what? 16 is equals to 16. Now 2 to the power of 16, this will give you 65,536. Again, on the AWS platform, only 65,531 is available for you. Where are the remaining 5? It has been reserved. The general IEE convention says that .0 and the last one on the block, .255, or whatever number it is, these two are reserved. One is reserved for the network, and one is reserved for broadcast. This is general. So any platform you get to, these two will always be reserved on any CIDR block. Either it is CIDR 16 or CIDR 28. These two will be reserved. Now, with these two, AWS reserved additional 3.1, which is for the virtual router, .2, which is for the mapping, okay, and .3, which is for future use. So on the AWS platform, whenever you have any CIDR block, know that out of the IP addresses available on that CIDR block, 5 has been reserved. And these are the 5 that has been reserved. .0 for the network, .255 for broadcast, .1 for virtual routing, .2 for mapping, and .3 for future use. That's just digression. The assessment says that we should allow SSH from a single IP address, but then they did not specify the IP address, so we just pick an arbitrary IP address. What the assessor want to test in that place is your understanding of CIDR block. That what CIDR are you going to give that IP address that will mean that only that IP address can access that firewall. Because if you say CIDR 16, on this block now, because a CIDR is a block, is a range, on this block, there are 65,536 IP addresses. Out of that plenty IP addresses, 5 has been reserved, so you can only assign 65,531. But how do you now specify a CIDR for a single IP address? Then you use CIDR what? 32. How do you know? It means that out of a possible 32 bits that an IP address can have, you have used up what? 32. Remaining what? 0. 2 to the power of 0 will give you what? 1. So on this CIDR block, there is only one IP address, and this is the IP address on this CIDR block. Okay, I give you a scenario. You are in an office complex, and there is a machine, there is a printer for the entire complex of 3 floors, ground floor, floor 1, and floor 2. And the printer is at the secretary office at the ground floor. So you that you are in floor 1 and floor 2, you need to print. You have to first send what you want to print to the secretary. He will now print for you, because it is only the secretary's PC that can send print job to the printer, that it will honor it. what has been done is that that printer has been locked to the IP address of the secretary's PC. Maybe you guys have abused the opportunity, you are printing anything prior to that rule. Okay, so you're just sending anything to the printer, you're wasting the company's paper, or the company just want to cut down paper usage. They want to be sure what you're printing is necessary to be printed. So they yanked off every other person from sending printing job from their own office workstation to the printer. And then they tied the printer to just one machine. What the networking guy or the admin has done is he has used a CIDR block of SATA32 on that printer to say that only this IP address is available on this CIDR block. Does that make sense? Hello, everyone. Does it make sense?
Yes, sir.
Okay, so you understand when the assessor says only one CIDR now? Okay. So let's move on. Okay, can you see my VS Code?
Yes, now. Yeah.
Yes.
Okay, so let's proceed. We've done for 22. Then we're going to copy again. This time around, RDP, Remote Desktop Protocol. Let's quickly check on Google. I think it is 3389, the port for Remote Desktop Protocol. RDP. RDP. Okay. It's also available on your AWS. If you go to security group and pretend as though you want to create a security group and scroll down to RDP, you will see the protocol for RDP, Remote Desktop Protocol. It means that only one system can remotely access the desktop of that instance, and only one system is allowed to SSH into that instance. Okay. Remote desktop protocol here. Let's click any one of these. If I click on EC2, I just want to show you that. Don't think it is it's not secret. It's something you can get anywhere. Yeah. Look at it here. TCP port 3389. That's it. And security groups. I want to show you as well. Okay. Oh, let's not waste time. Let's just move on. So this 22 changes to what? 3389. From that to 3389. It is still a TCP from any source. We leave it like that. Okay. The next thing we want to do is what? HTTPS from anywhere. So another ingress. This time anywhere. So the port here will be what?
000
0.
443.
dot.
Oh,
Oh,
Port.
443, right? That's the port for HTTPS.
Yes, sir.
443. Okay. Then when they say from anywhere, what would not be the CIDR block here?
0.0.0.0/0.
Thank you. That's it. I think I've changed the wrong one. Yep. I should be changing this last one here. Okay. TCP. So this one should be 0.0.0.0 CIDR 0. That thing you call slash is CIDR. Okay. Some of this diction, let us begin to pick it so that when you interact with the employer, they will know, okay, this is not a newbie. All right. So if we have declared 3 rules at the inbound, we need to specify for the outbound, don't we? By default, anybody remembers what the default outbound is?
Yeah, by default, every rules that is allowed in also can go out because security group is stateful.
Okay. So we say egress. Okay. Since it is any port, what we use here is what? For any port, what do we use? 0 to 0. And it can be any protocol. That's going to be -1. Let me show you. Look at the egress here. Can you see this egress? Egress means allow the default. This is an interview question. I've seen it in many interview, whatever responses and even questions on HackerRank, on Turing. I've seen it. The default state of AWS EC2 is that no rule at the inbound and all traffic at the outbound. Do you all copy that? Do you all copy that? You can test it out.
Yes.
Try and
Yes.
create an EC2. You will try to create EC2. Try and create a security group. If you try to create a security group, you will discover that it is at the inbound no rule and at the outbound, look at it. I'm trying to create security group now. Look at the inbound, no rules. Look at the outbound, automatically what? All traffic from anywhere. Do you see that? Okay. So here now, to set that port 0 from 0 to 0, then protocol -1 means all protocol, either it is TCP or UDP or ICMP. And the CIDR block is also from what? Anywhere. Okay, so having done that, let's quickly finish up. Then we keep here. Okay, the environment, DevOps. Let's save. So we have declared security group. What else do we need to do? It says we should create a network interface with a local or private IP address from the CIDR block we have in number 4. So let's come here and then let's find under VPC still network interface, ENI or ordinary NI. VPC Look at it, AWS network interface. Okay. So this is it. We copy and then we return and paste this. Let's call this one SAM public NI. Okay, in 2A. Subnet ID, we do not have it yet. So do we copy here? Put SAM public SN 2A. Let's be sure that's the name we gave to our public subnet 2A. Okay, that is it. SAM dash public subnet dash 2A. Okay. Private IP. So we're going to pick a value from the CIDR block of that subnet. Look at our subnet here. Look at the CIDR block. So we'll pick a value from here. And remember, you cannot pick .0, you cannot pick .1, you cannot pick .2, you cannot pick .3, you cannot pick .255 because those 5 has been reserved. So let's come here and pick 25.0.0.4. We can use .4. Okay. We are not attaching this network interface yet. So we don't need this attachment. What do? We comment it out. Okay. Which security group are we tying this network interface to? Our what? Our SAM public SG. As you're working, don't forget to save. So we have created a network interface. What's the next thing? We want to assign elastic IP to the network interface we created in number 7. Okay. So we come here and we look for EN elastic IP. So from experience, elastic IP is not under VPC. Where are we going to find elastic IP if it's not under VPC? In your normal
security.
AWS, where do you find elastic IP? When you're doing normal, did you assign elastic IP when you were working on AWS? Hello, everyone. Did you assign elastic IP?
Yes.
I know. Is it because you don't know that's why everybody is quiet? It's not as though you don't want to implicate this consultant. I'm sure you showed us. Where are we going to find elastic IP? Is it not normal EC2?
Yes, sir, it's under EC2, sir.
Oh, so why are you silent, sir? So let's go look for EC2 here. Look at it. Elastic Compute Cloud, you expand it. AWS, under resources, please. Under resources. Look at it, AWS EIP. Do you see that? Are we together? Hello, class. Are we together?
Yes.
Yes, sir.
Okay. So, resource EIP instance domain, okay. But look at this one because we want to put the elastic IP on where? Network interface and not on where? The instance. Okay, it is best practice that you put your EIP on the network interface, not directly on the instance. So we're going to use this one instead. Copy this. And then we paste. So let's also call this SAM EIP1. Domain VPC, that's correct. Network interface ID. Our network interface does not have an ID yet. So what do we put here? Let me know how many persons are following thus far. What do we put in this place, please?
The name we call the network interface.id.
And so what's that name called on Terraform?
Terraform this, okay, I think it's Sam Pub NI/2A, right?
Yeah, that's our own custom name for it. But the general name Terraform calls it is what? Who wants to bail us out? I've explained it.
Wait.
Is it main?
No, main is the custom name that Terraform uses on their own documentary. I called it when I was explaining this block, I called this the resource, I called this the resource type, and I called the next one a particular name. And I said it is only
It's
useful
true.
within this configuration file, the reference name. Don't forget.
Yeah,
Okay.
reference
So
name.
this IP address here will be the same one as the one on the what? Network interface. Okay. So this is going to be 25.0.0.4. All right. And then we save. So there is, this is not complete. This is red. Anytime you see anything in red in this ID VS Code, know that there's a danger. So what's the challenge here? Anybody wants to troubleshoot this red, this curly bracket? What are we supposed to do?
Supposed to close it down there.
Beautiful. So every bracket you open in scripting or in coding, it must be closed, either curly or angular. Okay. So we've done that. Let's save. I haven't saved. It says we still have one problem. Where's the problem? Okay, this guy here is a dash, not a dot. Look at it here. Some public network interface 2A. Okay, instead of saying public, just put ENI, Elastic Network Interface. ENI 2A, and then save. Number 8. Now number 9, we launch an EC2 instance. Okay. But look at this, our EIP here. There's something we need to introduce. If we come to this documentation and we scroll down, look at this. Depends on this. If you have, what do you think our elastic IP address can depend on? Or let me explain better. What do you think must be in place before you can actually have an elastic IP address?
EC2.
No.
No? What?
Yeah, you can create an elastic IP address without creating a EC2 and later go and attach it.
A network
Yeah.
interface.
Not really. You can decide not to put it on network interface. It's just a best practice, but you can decide against it. Internet gateway, right? I have a VPC, and that VPC does not have internet gateway. What does that mean? Are we together?
It can't
Yes, sir.
see, so it can't connect to the public network.
It means that VPC is local. There's nothing, that VPC cannot be on the internet.
It's a private VPC.
Internet cannot access it. Neither can it go to internet because it doesn't have a what? A VPC. So now, sorry, it doesn't have an IGW. Now, if a VPC cannot go to the internet because I did not attach internet gateway, So what is Elastic IP address doing on any resource within that VPC? Is it useful?
It's not useful, it's useless.
It's not.
Stay idle.
Are you getting the logic, everyone? That's why I said initially that before you can be able to use Terraform appropriately, you must understand very well the provider platform you want to use Terraform for. Because if I say I have a house and I fenced the house round, mortar and brick, and there is no gate, not even pedestrian gate or even vehicular gate. I just fenced it around. And I gave you the address to my house. Of what use is it? Because when you get to the house, you can't enter. Even me, I can't enter because I fenced it around. So I created a VPC and I did not put internet gateway. And I'm creating resource within that VPC and I'm giving that resource Elastic IP address. Of what use is the Elastic IP address? It's useless. That's why we are saying put this depend on here, meaning that if you did not see internet gateway anywhere within this configuration file, either in vpc.tf or in provider.tf, then do not create this Elastic IP. As simple as that. So what we are saying is create Elastic IP address only if you have found internet gateway. Now, this is not asking for ID. It's only saying depends on what? Internet gateway. So what is going to be here is just our what? IGW. You will not put .id because it is not asking for what? ID. Okay. Again, when you see this kind of angular bracket in Terraform, even in scripting, it means you can list more than one item. Okay. Are we together? So
Yes, sir.
we save it. Now you will now be like, okay, why do I have to put depends on here? Since I've already created internet gateway in this place, Terraform is a declarative tool. If I create VPC from this place, if I cut it and I bring it to the last point here, nothing has happened though. It will still go ahead and create normally. Unlike when you are scripting in Linux, bash script, that you must list your commands in sequential order. HashiCorp configuration language doesn't work that way. Irrespective of your ordering, it will still reorder it by itself when it is what? Implementing the script. Okay? And that's because we have reference name referring one thing to another. Okay, because if number 2 is the first thing here, and the number 2 says use the VPC ID of SAM VPC, that means it will be forced to look to the entire configuration file and look for a resource block that its reference name is bearing what? SAM VPC, and create that one first because it will need that one to be able to create internet gateway. Why? Because the ID of that one is needed in this place. So irrespective of your ordering, Terraform will still work. If you now want to force Terraform to ensure that this particular thing is created before you create the next item, then you use this kind of function, depends on. I hope it makes sense. Does it make any sense? Hello, everyone. Are we together?
Yes, we're with you.
All right. So Having kept depends on here, let's go to the last one, which is launch EC2 instance. Okay. So we come here, we look for EC2 AWS instance in this place. So you see that the documentation is there. All right. It's just you that you must know what you are looking for. And again, Copilot will also give you idea. It is also you that you'll be able to tell Copilot the direction you are going is my direction or not my direction. Look at this one here. AMI, instance ID, subnet, key name, security group. Of course, all these ones are what we needed. Okay. But then it is not complete. Okay. But I can just tap down here and it will reference all of this. However, let me show you where that is. Under AWS instance, this is under EC2, not under VPC. Okay. So I'm looking for, there are different resources here. Look at this resource, AWS instance. You will need all these functions. You don't have all these functions. So we keep looking. This one is creating subnets. We don't have that. We already done that. Look at this one. AWS instance, right? AMI, okay. Instance type, network interface. So this instance is automatically being attached to this network interface. This looks like what we are looking for. So I'm going to copy this. Even though it has already been pasted here, I'll still paste so you can see. Look at this first three line. And this first three line is what we're looking for. Okay. So you notice that this guy does not even have this guy we are looking for here. Okay. So this is beautiful. Yes. But let's stick to this. So I'm going to go to EU West 2 and copy AMI ID in that place. Instance type T2 micro. Network interface. The network interface we created here. Look at it. We will now keep it here because it is that network interface that will be attached to this EC2 instance. For this EC2 instance to automatically carry the elastic IP address. And don't forget, a network interface is attached to a subnet ID, right? So we then know automatically that this EC2 will be within this subnet. And also don't forget, when we were creating this subnet, we decided to keep it in availability zone 2A, EU West 2A. So that also means that this EC2 instance will be where in EU West 2A. So that ripple effect goes on and on and on like that. Okay, first let's close this bracket. Good. So what do we call this VPC? We call it SAM VPC. It's gonna be T2 micro. Okay. Do we want to give it a key name? SAM key, that is, if you already created a SAM key. Otherwise, let's use the one we have in that place, London KP. Okay. We also have been asked to give it what's the size of elastic block store.
The EBS storage, 12 gigabytes.
12 gig, right? So we need to put a root block device. Okay. So we come here. root block device, volume size what? 12. Okay, if we did not put this root block device, the default value it will give it is what? 8 gig. Okay. This network interface, this guy here will change to what? ENI 2A. Is that the name we gave it? Let's go and check. Okay, SAM ENI 2A, that's it. Then we go to London region and we copy AMI. So let's go to London region, EC2. Now, the AMI of Ubuntu 20.04 in London region is not the same as in another region, even though they are the same Ubuntu 20.04. Do you copy that? If you copy that, repeat what I said or explain what I said if you understand what I just said. Hello? Who understood what I just said? Who can quickly explain? Our time is fast spent. Let's work fast.
You said every region has unique AMI.
Beautiful.
They are
It's
not the same.
as simple as that. So, because you have the AMI of Ubuntu 20.04 from North Virginia, that does not mean it is the same as the one in London. So don't make that mistake. Okay. So I copy this AMI and then I'll replace what is here. And to be sure, I add this comment that it is EU West 2. Okay. I can even say it is Ubuntu 20.04 AMI that is here. Okay, so whoever picks this knows what I have done. Save. Do we need to give it a tag? Yes, let's give it a tag.
Hello, coach.
Go ahead, sir.
Sorry, looking at the resource name for the EC2. I'm thinking it's supposed to be SAM EC2, not VPC.
Oh, thank you. Sam Server 1. Thank you for that. You would have spotted it as an error, but yeah, we've corrected that. So let's save. Okay. Now we have completed scripting. How many lines of codes? 146 lines. So you save. The next thing you want to do now is to what? Validate. So if you run Terraform validate, let's see what we are getting. While we are validating, you can ask your questions if you have any.
Or why creating the key pairs? Let's assume you didn't have a key pair and you want to create a new one. So how will you
Beautiful.
go about that?
Beautiful. You come here and search for key pair. Look at it here. Do you see this? Resource, key name, this. Do you see this? So the public key is this, and email at example.com. What is this for? Okay, you might not. Let me give you a clue. When you're working from the GUI, from the AWS console, when you create a key pair, what happens immediately?
It will download it. The CSV file will download it. Right?
Okay,
And
the one
give
is
it, give
downloading
it a
is what?
name. The one is downloading would be your private key.
Beautiful. So what do you think this one is now going to do if you are doing it from the command line? If you are creating a key pair from the command line, this your email.
Send the private key.
Beautiful. It will send the private key file to your email for you. So once it creates it, the next thing you will see in your inbox is what? Your mailbox is the private key file.
Ah.
Does that make sense now?
Oh, thank you.
So it says our configuration is valid. Now let's go and run Terraform plan. Let's run Terraform plan now. So what will Terraform plan do for us? Who remembers? What's Terraform plan going to do for us?
It will display the configuration you're about to create.
Beautiful. It will show you that this is what you are about to what? To do. So it says we're about to create 9 things to add, 0 to change, 0 to destroy. So if there's no error, what do we run next? Terraform
Apply.
what? Apply. If you want to automatically answer yes, you put auto approve. Okay. So our time is spent in the next class. We will now extend this to as though we want to create a full-fledged VPC. You know, this VPC does not have private subnet. It doesn't have private route table. It doesn't have NAT gateway, right? So in our next video, we will extend this assessment so that our VPC we have 2 public subnets, 2 private subnets, 1 public route table, 1 private route table, 1 NAT gateway. Okay, and we'll see other things like that. Okay, so let's see. We have one error. It said London KP does not exist. Let's quickly go there. Okay, and let's check if there is a key pair like that in London region. Okay, key pair. Oh, look at the name. Mo London key pair. So it says on line 128. Let's go look at it here. Line 128. Line 128. Look at it. So put the appropriate value. So you see that it is not a technical problem, and that is why Terraform validate did not spot it. So if we've put the right value and we've saved, we run Terraform auto approve again. We're waiting for Terraform auto approve. While we are waiting, let's go to our London region. Let's click on VPC. to see if it has created anything at all. We have two VPCs here. AWS has redesigned this thing. Look at it, SAM VPC. Look at the CIDR. Okay, and we click on SAM VPC. Let's go look at the resource map. Look at it. SAM public subnet 2A, that's the tag associated with the public route table, SAM public route table, connected to SAM internet gateway. Okay, can we see the subnet? I think we created just one public subnet. Yep. Look at it. 25, the CIDR block out of 256 that we expect this guy to have. Okay, I hope you know that this is 32 minus 24, and that is 8. 2 raised to power 8 gives us 256. But then we have 250 here. We know 5 has been taken, received by AWS, and we also used one for the network interface. That's why we have 250 remaining in this place. Let's go check the route table. Look at SAM public route table. We click on it. We see that it has both local route and the what? Internet gateway route. So that one is settled. Okay. We created an elastic IP. Let's go here. Elastic IP. We should be able to see SAM EIP or whatever name we gave to it. Okay, we didn't give it a name, but it is here. Look at the private IP address on it. We didn't give it a name. Let's check. Okay, autocomplete resource one added. So yeah, our configuration script worked. Let's quickly check the elastic IP. We say assign elastic IP. We didn't give it a tag. That's it. We didn't give it a tag. If we give it a tag here and run it again, it's going to say one modified. It's not creating it afresh. It's going to be modified now. So I'm going to send you all of these configuration files. Okay, let it guide you to build this kind of project as well. Okay, I'm going to put it on the, I'll give it to Lady Anne. She's going to put it up either on GitHub or put it on the Telegram group. Okay, so let's continue looking at what we've done. So we've confirmed the Elastic IP. Can we also confirm security group? We called it SAM public SG. Let's also confirm. Look at it here, SAM public SG. We said you should allow, we said it's inbound rules. RDP from single source, HTTPS from anywhere, SSH from single source. That's beautiful. Let's return by one step and let's check the outbound rules. Look at the outbound rule. All traffic. All traffic. That's fine. Can we quickly go check our EC2 then? We've confirmed that it is in a London region. See the instances running. SAM server 1, T2 micro. Is that in tandem with what we are asked to do? T2 micro, that's correct. We've confirmed London region. We've confirmed line 5 and line 6 in this place. Can we confirm the storage size on it? Let's go confirm. Okay, we have to click and check the storage. The root block, 12 gig. Excellent. Is that what we asked to do? 12 gig. So it's a simple project, isn't it? Who are still with us? 6 person. We started with 9.
Yes, sir.
We are down to 6. Not bad. So that's it. Complex projects are still on the way. Thank you, Mr. Isaac, for pointing the reference name for the EC2 out. Okay, but we're gonna take it like this, and I'm sure by the time we are neck deep in this, nothing in DevOps and cloud, especially AWS, become special to you again. Any question?
I shall.
Any questions, please? All right, if there are no questions, like I said, I'm going to send the document, these script files to Lady Anne. She's going to decide if it's going to be through GitHub or put it on your Telegram for you to access it. And the class video will be made public for everyone. Okay, so don't look for it within your class playlist. Okay, the class video will be publicized and then you can access. All right. So if we're going to continue,
How?
the class video will be made public. The link will be sent to your Telegram group. That's what I mean. Okay, so don't watch out for the class video on your class playlist, no, because this is not a boot camp. This is a project session. Did you get that? All right, so we've come to the end of this session. Thank you, everyone. If we're going to have class on Saturday, I'll let us know so we can expand the scope of what we have here. All right. That's it. Keep practicing and keep seeking for what you desire. You will get it if you don't relent. Goodbye, everyone.
Thank you. Goodbye.
You're welcome.
Thank you, Mr. Bafan.
Thank you, sir.
Thank you, coach.